In this video, we are going to compute the inverse transform of functions of the form e power of minus as into f bar of s. So in the previous video, we have discussed the definition and a few examples and the formulas of the inverse Laplace transform. So here in our next topic, we will be finding the inverse transform of functions of the form of an exponential function multiplied with some function of s, that is e power of minus as into f bar of s. So this is one of the property, that is we already know this property, that is Laplace transform of f of t minus a into u of t minus a is given by e power of minus as into f bar of s. So L inverse of e power of minus as into f bar of s is given by f of t minus a into u of t minus a. So here we have a working procedure to find the inverse transform of functions of the form of e power of minus as into f bar of s. So in our step 1, first in the given function we should observe the presence of e power of minus as. In the sense, first in the function we have to check whether we have a function of the form e power of minus as or not, and then we have to identify the remaining part of the function to be called as f bar of s, and the remaining part of the function we have to assume it as f bar of s. So next in the step 3, we have to take the inverse of f bar of s and then we'll obtain f of t. So in our step 3, the required inverse of e power of minus as into f bar of s is obtained by replacing t by t minus a in f of t, and then it must be multiplied with the unit step function u of t minus a. So we will understand better when we move on to an example. So here we have to find the inverse Laplace transform of the given function, that is the following function. The given function is 1 plus e power of minus 3s by s square. So here we have a solution. So first let us split the given function into two functions, that is one function is 1 by s square plus another function is e power of minus 3s by s square, that is e power of minus 3s into 1 by s square. So the L inverse of this term is equals to L inverse of 1 by s square plus L inverse of e power of minus 3s into 1 by s square. So using the standard result, that is L inverse of 1 by s power of n plus 1 is given by t power of n by n factorial, so where my n will be equals to 1 for this particular term. So I'll get t power of 1 by 1 factorial plus, so now observe this term contains an exponential term of the form e power of minus as. So and then the remaining part of the problem we have to identify as f bar of s as in the step 1. So look at this problem. First we have to check whether the given problem contains these two terms, that is one exponential term, and rest all terms must be identified as f bar of s. So in this particular problem, so we have to observe the presence of the exponential function, that is e power of minus 3s is the exponential term, and rest all function, that is 1 by s square, must be identified as f bar of s. Okay, so according to this property, so this function L inverse of functions of e power of minus as into f bar of s is given by f of t minus a into u of t minus a. So a is the coefficient of s in your exponential term. Okay, except minus, whatever the coefficient of s will be there, that will be your a. So here in this particular term, the coefficient of s is 3 except negative sign, so a is equals to 3, and according to the property f of t minus a into u of t minus a, that is f of t minus 3 into u of t minus 3. So now let us find the value of f of t minus 3. So we already know this result, that is f bar of s is equals to L of f of t. So that f of t is equals to L inverse of f bar of s. Let us take the inverse function for f bar of s. So what is our f bar of s? F bar of s we have identified as 1 by s square in this problem. So let us substitute f bar of s, that is 1 by s square. So according to the formula of L inverse of 1 by s power of n plus 1, so we have t power of n by n factorial, so where n is equals to 1. So that we will get t power of 1 by 1 factorial. Since we need the answer for f of t minus 3, let us replace t by t minus 3. So if we replace t by t minus 3, in this result we will be having f of t minus 3 is equals to t minus 3 by 1 factorial. The 1 factorial value will be 1. So f of t minus 3 is given by t minus 3 itself. So let us substitute in the place of f of t minus 3 as t minus 3 to get the final result for this problem. So the final answer will be t by 1 factorial. The value will be 1. So we will be having t by 1 plus f of t minus 3 is t minus 3 multiplied with u of t minus 3. So let us go through one more example for better understanding of this property. So here our next problem is 3 by s square plus 2 into e power of minus s by s cube minus 3 into e power of minus 2s by s. So we have to find the inverse Laplace transform of this term. So now first let us take inverse Laplace transform on both sides for each of these terms. So that will be having 3 is a constant, keep it as it is. So we have to find L inverse of 1 by s square plus 2 is a constant, let us keep it as it is, and we have to find L inverse of e power minus s into 1 by s cube minus 3 into, we have to find L inverse of e power of minus 2s into 1 by s. So now let us apply the inverse transform formula here. So 3 is a constant, keep it as it is. L inverse of 1 by s square is given by t by 1 factorial plus 2 is a constant, let us keep it as it is. So now observe the presence of exponential terms here. If we have an exponential term, we have to make use of this property, the currently what we are studying, that is Laplace transform of e power of minus as into f bar of s is given by f of t minus a into u of t minus a, where a is the coefficient of s except the negative. So we will be having a value will be equals to 1. So we will be having f of t minus 1 into u of t minus 1 according to the property, minus 3 into, again here f of t minus 2 into u of t minus u, because the value of a will be equals to 1. So now let us first find the L inverse of e power of minus s into 1 by s cube. So here L inverse of this function is given by f of t minus 1 into u of t minus 1. Here let us find the value of f of t minus 1 in this term, and here let us find f of t minus 2 in this term. So first let us find f of t minus 1. For that you have to follow this step. So this is L inverse of e power of minus s into 1 by s cube. So here the value of a is 1 and f bar of s is 1 by s cube. So Laplace transform of f of t is equals to, f bar of s can also be written as L of f of t, which will be equals to 1 by s cube. F of t is equals to L inverse of 1 by s cube. So f of t is equals to t square by 2 factorial by using the formula. So now in this equation, since we need the value of f of t minus 1, let us replace t by t minus 1. So that will be having f of t minus 1 is equals to t minus 1 the whole square by 2 factorial. So this is the value of f of t minus 1, where we have to substitute back in our equation number 1. In the same way, let us find f of t minus u for this particular term. For that, L inverse of e power of minus 2s into 1 by s. So in this function, we have to identify our f bar of s, which is given by 1 by s, and the value of a is equals to 2. Therefore, L of f of t is equals to 1 by s and f of t is equals to L inverse of 1 by s. So, according to the formula, f of t is equals to 1. Here, let us replace t by t minus 2 because we are finding the value of f of t minus 2. So, therefore, f of t minus 2 will be equals to 1. So, let us call this as equation number 3 and this as equation number 2. And let us substitute the values of equations 2 and 3 in equation number 1. So, that will be having 3t plus 2 into 3t plus or equation number 1. So let me show you. 3t by 1 factorial is 3t itself plus 2 into f of t minus 1 value is t minus 1 the whole square by 2 factorial. So let us substitute in the place of f of t minus 1 and u of t minus 1 will be as it is minus 3 into f of t minus 2 value is given by 1 and u of t minus 2 will be as it is. Therefore, the required inverse Laplace transform of the given function is given by 3t plus t minus 1 the whole square into u of t minus 1 minus 3 into u of t minus 2.